We're going to talk about kinematics. And we're going to talk about motion in 2 dimensions, 2D. And we're going to solve a problem. So for motion in 2 dimensions, we have our coordinate system right here. And okay, we have a particle that has an initial velocity. This is the initial velocity. And it has an angle theta. And the particle has VO, which is initial velocity. And let's say the initial velocity is going to be 60 meters per second. And the angle is going to be 60 degrees. And let's say that this is under the influence of gravitational field. Here's your gravitational field G, and it's negative because it's coming down. So you have a particle that is going to be launched with some initial velocity, which is 60 meters per second, and a launch angle of 60 degrees. And it's going to do something like this. So it's going to come and it's going to land over here. And we have here what's called here this would be your maximum height. Okay. This would be your maximum height. And well, there's a time that this particle takes to go from the origin all the way to the maximum height. And we can calculate the time to reach maximum height. Okay. We can calculate the maximum height. All right. We can calculate the total time of the flight. And we can calculate the range. And the range would be all this distance from here to here. That would be your range, the distance for to go from the origin to the point where your particle is going to land. This is where you're going to land right here. You start at point A and you're going to land at point B. And that would be maybe distance. That would be your range. So the equations we can use would be for the maximum height. It's going to be VOT. Okay, the equations for the maximum height are going to be, let me make this a little better. Equations for the maximum is going to be VO sine of theta times T minus 1/2 of G T to the square. This is G to the square. X is going to be VO cosine of theta times T. And the velocity in the Y direction is going to be VO sine of theta minus GT. And the velocity in the X direction is going to be VO cosine of theta. Okay, so and then we have another equation for the range. The range is going to be VO to the square sine of 2 theta over G. So we have all these equations to play around with. So we have this equation to calculate the maximum height, this equation to calculate the displacement in the X direction, this equation to calculate the velocity in the Y direction, and this to calculate the velocity in the x direction, and this to calculate the range. We have all those equations. So we're going to break this guy down in components. We have one component that goes this way, and another component that goes this way. So this one would be VO in the x direction, which is going to be this guy. And this one would be VO in the y direction, which is going to be this guy right here. This is going to be VOY, which is the component that goes in the y direction. And what's going to happen is that this component, the one that goes in the y direction, is going to be, every time it's going to be smaller. It has going to have less magnitude. And when the component in the y direction of the velocity reaches the point of the maximum height right here, this guy right here is the point of the maximum height, it's going to be 0. So the velocity in the y direction is going to be 0 at the maximum height. This is the maximum height, and that's where your velocity is going to be 0. So you can use that fact with this equation right here, this one right here, to solve for the time that it takes to reach the maximum height. So this equation is going to be used to calculate the time that it takes to reach the maximum height. So we got 0 is equal to VO sine of theta minus GT. And we can send the GT to the other side. So GT is going to be equal to VO sine of theta. And then we divide by G, and we divide by G. We cancel G with G. So the time to reach the maximum height, is going to be VO, which is 60 meters per second. And that time, the sine of 60 degrees, which is 0.866. And we're going to divide that by 9.8 meters per second square. So the time to reach the maximum height is going to be equal to, if you do all that math, the time to reach the maximum height is going to be 5.3 seconds. So this is going to be the time to reach the maximum height. And we have solved this part here. This is going to be 5.3 seconds. And then the maximum height, well, the maximum height, let me use another color here. The maximum height max is going to be, well, we have the equation right here. It's going to be this one. So it's going to be 60 meters per second times the sine of 60 degrees, which is 0.866. And now we have the time, which is 5.3 seconds minus 4.9 meters per second square, which is G divided by 2. And now we do have the time, which is 5.3 seconds elevated to the square. So the height, the maximum height is going to be equal to, if we solve all this math, the maximum height is going to be equal to, well, this first part is going to be 275.22 meters. Okay, because seconds are going to cancel with seconds and you only have meters, minus, same thing here, this second goes to the square, second goes to the square, it's going to cancel with this second to the square over here, and 5.3 to the square times 4.9 is going to throw you 137.64, something like that, meters. And we have the same units, so we can add these, we can subtract this. So it's going to be 137.6 meters. And you have your maximum height. That would be this one. That would be 137.6 meters. And now the time of total flight is just going to be twice the time to reach the maximum height. This is the maximum height, because the same time it takes you to go, let's say from, okay, let me use another color here. Let me use the green. To go from here to here, if you follow the green curve, that would be the path to reach the maximum height. So that's the path. But the time it takes to reach the maximum height from the origin all the way to the point of the maximum height is 5.3. And then you go back again, go back down, and it takes you the same time to go from the point of the maximum height to the floor over here. So that's going to be twice 5.3 seconds, and that's going to be 10.6 seconds. And so you got your time, it's going to be 10.6 seconds. And then you can calculate the range. The range is going to be this equation here. So it's going to be 60 meters per second elevated to the square times the sine of 60 of the sine of 120. It's going to be the sine of 120 degrees, and it's going to be divided by 9.8 meters per second square. And if you do this math, this is going to throw you 318 meters, and this would be the range. So the range is this one. So the range is going to be 318 meters. And you have solved this problem. This is motion in 2 dimensions. And this is the motion of a particle under the influence of gravitational field. And this is parabolic motion. This is one example of motion in 2 dimensions, a particle that moves under the influence of gravitational field. Thank you. And